Okay, this is one of the sticky problems from the Wiley Plus set. It's actually number 67 from the book. Some of us got different numbers, but that's what it does to the problems. It's about two functions being inverses, and they start asking for lots and lots of values. I want to go through this. Basically, we defined inverse functions as ones you get by such switching the x's and y's. And I just want to see how much of this we can actually do just with tables and see if we can make it work. So they told us that j of x equals h of inverse of x. So what I'm going to do is start making a table for h. So this will be a table for h. Don't know how far down I'm going to have to go here. Like that. And I also want to have a table for j, because we're going to need them both. Like this. And let's just start filling in stuff. For example, they told me that h of 4 was 2. So I'm going to put a little 4 right here and a little 2 right here. Now, remembering that this is the inverse table, we know automatically then that this is 2 and this is 4. Now, how am I going to read this? I'm going to read this, and when you plug 4 into h, you get 2. So h of 4 is 2. When you plug 2 into j, you get 4. So that's the same thing as saying j of 2 is 4. Now, the other piece of information they gave us was that j of 5 equals minus 3. So that says in this table over here, j of 5 is minus 3 like that. But h and j are inverses. So that says that over here, I can put a minus 3 and a 5 like that. Now, again, I'm going to read this, that h of minus 3 is 5. So when I plug minus 3 into h, I get 5. I'm going to read this over here, that j of 5 equals minus 3. So when I plug 5 into j, I get minus 3. Let's do one little creepy thing before we move on. They didn't actually ask this, but I think it's a good idea to do this. I'm going to put a little 10 right here. They didn't tell me what that was, right? I do know, however, that I should get h of 10 here. Now, once I have something in this table, I automatically get something in this table. So I know that h of 10 here is automatically 10. Don't put an equals. Let's put a 10. Let's go like that. Now, watch what we get to do just by reading, right? We knew that h of 4 is 2, h of minus 3 is 5, h of 10 is h of 10. No kidding, right? Now, j of 2 is 4, j of 5 is minus 3, j of h of 10. J of h of 10 is 10. The table gives us that for free. All we have to do is know how to read the table. I know that sounds easy, but math reading is usually pretty hard. Now, I'm going to start running through these things. I'll have to erase as I go, but you have it here, so I'm not going to fuss too much. The first thing they asked of, I think, was j of h of 4. So the first thing they asked in part A was j of h of 4. Now this one we actually don't have to think too hard, because h of 4 is 2, so this is just the same thing as j of 2. And I can see from my blue table over here, j of 2 is just 4. So for part A, we get j of h of 4 is 4. They're trying to teach us a lesson here, though. J and h undo each other. Whatever h does to 4, j undoes it and gives us 4 back. This is going to be something we're going to be hearing over and over and over this semester, especially with logarithms and with inverse trig functions, but there are other things as well. Now, in part B of the problem, they asked for j of 4. Now, I'm just looking here and seeing what I know. I know that h of 4 is 2. I don't know that. I don't know j of 4, right? There's nothing here that gives me j of 4, so this is going to be not available. And there's nothing I can do to fix that. But I don't have to think on that one either. Once I have it organized, or I understand it, either's fine, we can just move forward. The next part of the question, they asked us for h of j of 4. Now before we do this, and we'll do it, remember that h and j undo each other, right? So whatever evil thing j does to 4, h is supposed to completely undo it and give me 4. Now let's check. Start from the inside, work your way out. J of 4. Oh boy, I don't know how j of 4. Okay, let's make a little table here. See if we can do this, right? I'm going to go like this. I know that j of 4 goes here. J of 4 goes here. Oh boy, here we go. If 4j of 4 goes here, j of 4 here, 4 goes here. Now how do we read this table again? H of 4 is 2, h of minus 3 is 5, h of 10 is h of 10, h of j of 4 equals 4. And so we thought it through, we did it with the table, although it was a little bit awkward, but we got there. That was part C. Now, just going to keep working through the problem because they're just making us, trying to think and make us read, both of which are good, both of which are hard. For part D, they asked for j of 2. Table says j of 2 is 4. That's nice and easy. Happy about that one. Just moving through the problem. This is a book problem, so you see the book in front of you, right? Here we go. Now they ask for h inverse of minus 3. H inverse of minus 3. H inverse of minus 3. I know h of minus 3. I know that h inverse is the same as j of 3. I'm sorry, j of minus 3. But I still don't know that. I know well, what do I know? I know j of 5 is minus 3. That's all I got. This is not available. There's nothing I can do to make this one work. It's uncomfortable, but some stuff we just don't know. It's all right. Let's see here. They also wanted j inverse of minus 3. So this is part F in the book. They want j inverse of minus 3. J inverse of minus 3, well, h is j inverse. So this is h of minus 3, and you get 5. Now, if I'm trying to think with the notation, because that's what we're trying to do, what are we supposed to do with j inverse? We're supposed to look for minus 3 in the answers, way over here, and j inverse is supposed to give us the original input, which was 5. So we can use table to do that. We can think with that. We're going to need to be able to do both when we start logarithms next week. So this is coming. Now, part G of this problem was h of 5. H of 5. I don't know h of 5. I mean, you can look over here. I don't know h of 5. There's nothing I can do with that. So this is not available. Now, by the way, what's weird, if they asked for j of h of 5, which, they didn't, j of h of 5 is going to be 5. Because whatever h does to 5, j undoes it and gives you 5. You can do that with the table. You can do that with the thinking. We're going to need both. So that's part G. Part H. They asked for something completely different here. They asked for h minus 3 reciprocal. Reciprocal. This is not asking for the inverse function. It has nothing to do with the blue table over here. Nothing, right? What this is just 1 over h of minus 3, like that. Well, we know h of minus 3 is 5, right? So we're just going to get 1/5 here. But it has nothing to do with inverse functions. This minus 1, because it's about the whole value, not just h. It's not the inverse function. It's the reciprocal. So that's h. And again, if you're having trouble with this, just stop the video and watch whatever you want. The last thing they asked for was h of 2. And they put a little minus 1 over here, but I'm going to read that reciprocal. If it was h inverse of 2, we would use the blue table. But this is not about the inverse function. This is about the reciprocal value. And again, the reading gets to be very important here. This is going to be the reciprocal of 1 over h of 2. But I don't know h of 2. There's no way to get h of 2, so this, again, is not available. And that is the famous number 67. It's not so much important for the test, although it might appear somewhere on it. It's much more important for the inverse function stuff that we will need when we do logarithms.